All right, this is a video. This is the second part to 701. And in this one, we're going to do some practice problems for sex-linked traits. And what I have to start with is in humans, hemophilia is a sex-linked trait. Females can be, one second. Females can be normal carriers or have the disease. Males will either have the disease or not, but they won't ever be carriers. And I'm going to rewrite this because it's a little difficult to see. So I have X capital H is a normal female. I have X capital H, X lowercase h, this is a carrier. And I have X lowercase h, X lowercase h is a female that has hemophilia. And it is possible, but she has to have two traits. And remember from our first video, you have to have two parts. You have to tell me if it's a male or female. And then as an exponent, you have to put the disease gene. Over here, males only have two possibilities. You have X, capital H, Y, or that's normal. You can have X, lowercase h, Y. So just to be clear, capital H is a normal, lowercase h is hemophiliac. You write the whole thing out. What we're going to do is we're going to show a cross of a man who has hemophilia with a woman who is a carrier. How many children will have the disease? So let's start off. We need our genotypes. If we have a male who has hemophilia, he is going to be XY. And then as an exponent, we're going to put lowercase h. Remember, the Y chromosome does not carry a disease. We have a woman who's a carrier. She is XX because she's a woman. And then the disease gene is capital H, lowercase h. She has a copy of the gene, but she does not have disease. She's a carrier. So let's do our Punnett square. All right, I always like to put the female at the top, lowercase h, and the male on the side. Doesn't have to be that way. That's just kind of what I like to do. So let's go ahead now and bring down our alleles. So the first allele, the first box is a female, and she's going to be heterozygous. Second box is a female, and she's going to have the disease. Third box is a male because he's going to be XY, and on the X chromosome, we've got a capital H, so that's normal. And now we have a male who has XY. So remember, sometimes we have to analyze this as male or female, but in this problem, it just says how many children will have the disease. So we don't have to split it out by male and by female. Sometimes you do, sometimes you don't. This is normal. Actually, this is a carrier. This is normal. But these two both have hemophilia. So how many children will have the disease? 50%. So that's not a good, that is not a good cross. I knew a family in the area, and their kids, they were driving, and the dad had a fender bender. The kids hit their seatbelts. They took them to the hospital. They called in children's services because they were bruised so badly they thought the parents had been abusing them. Well, it turns out it was a boy and a girl, and they both had hemophilia. So that meant that the dad, now you can have, actually males can carry it, and it's not extremely bad. The dad had always bruised easy. He didn't realize he had it, but it was an example of this where mom was a carrier, dad had a mild case, and the kids both ended up having hemophilia. You had to be really careful for their whole life. All right, the next one, in cats, gene for calico, multicolored cats, is codominant. Females receive a B, and females that receive a B and an R gene have black and orange. And the reason that's capital like that is they're saying orange is going to be capital R. Splotches on white coats. Males can only be black or orange, but never calico. Show the cross of a female calico cat with a black male. All right, so let's start off again. Let's do our genotypes. So a female calico, female is going to be XX, male is going to be XY. This is the first thing you want to do. You want to put down your base. Now, we're talking codominance. So a female that is calico is going to have a black gene and an orange gene. The male is going to be black, so he is going to be XBY. So B is black and R is orange. And I'm going to go ahead and do the cross up here in this area because we've got not a lot of nice space up there that's not used. My box. And I'm going to put the female along the top. She's going to be X capital B, X capital R, and our dad is X capital B, Y. So we're going to go X, B, X capital B, X capital B, X capital R. Now we've got boys, XY, black, XY, R. So this just says show the cross. So let's talk about our results here. Let's say the question says, what are the possibilities for males and females? So if we look at our females, remember females are here. It's these two boxes, and our males are here. So our females should end up being 50% black, 50% calico. Because remember, if you get a black and an orange, you're a calico. Males, on the other hand, are 50% black. That means the same thing. But the other possibility for males is 50% orange. Because this is a sex-linked trait, the males only get one allele, they can never be calico. And this is true. If you see a cat and it's got a white coat and it's got black and orange splotches on it, you know right away that it's a female. So that one holds true. There's your trivia for the day. Okay, you've got some problems to practice with for homework. So let's get you started on those. Thanks for watching.